Hello, dear friends. In this discussion, we are looking at PERT, which is Program Evaluation and Review Technique, a project management technique used to do what we call planning, scheduling, and controlling uncertain project activities. So if you have project activities that are not certain or where you cannot tell the duration, then you use estimates. And these estimates are going to be weighted averages of pessimistic, optimistic, and most likely. And the optimistic one is the shortest possible time to complete the task, and the longest time the task might take is what we call pessimistic, and the most probable duration based on past experience is what we call most likely. So, PERT is a probabilistic approach, meaning that we are basing on estimates to determine the duration or to determine the expected time to execute given project activities. So now, once you are given the optimistic and most likely then plus pessimistic estimates, then this is how you get the expected duration. So expected duration is therefore going to be, we are going to use T O, which is the optimistic time estimate, plus 4 times most likely time estimate based on experience, then plus the pessimistic time estimate divided by 6. So that's how we do it. So now we have two experts, A and B, who examined an activity and arrived at the following time estimates. The optimistic time is 4 for A and 6 for most likely time and 8 for pessimistic. Then for B, he said this is 4, this is 7, and this is 10. Determine which expert is more certain about their estimates of time. So what we are going to do is to actually do the standard deviation. So the standard deviation is actually going to tell us a standard deviation or variance. We can even do variance. So these are actually measures of dispersion, okay? Measure of dispersion or variability of the duration estimates. So if we get a larger value, then that means there is more uncertainty. If we get a smaller value, then that is going to be of less certainty. In other words, it is most likely to be the value. Now, if we are to say they were more certain about their estimates, we are going to determine the variances here and get the one which is smaller. The one which is smaller will give us an expert whose estimates were at least we can say the expert was certain or was closely to certainty. So let's begin with A. So variance is actually equal to TP, or the pessimistic, minus what we call the optimistic divided by 6, and everything is squared. So this is going to be what? So we have TP for A. This is going to be 8 minus 4 divided by 6 squared, and this is going to be 4 divided by that. So that is 4 divided by 6, and everything is squared. So this is 4 divided by 6. So this is, let us use 16 divided by 36. And if I take square root to get standard deviation, is square root of var, and this is square root of 16 out of 36. which gives us 0.67. Now let's look at B. So var is going to be TP minus T naught divided by 6 squared. And this was 10, 10 minus 4. And this is 1. So standard deviation is equal to square root of var, square root of 1, and that is 1. So we can say that expert A was more certain about his estimate of time. So expert A was more certain about estimates